Okay, so a little bit of progress on this thing. I think the last time I showed this pretty much exactly fit the way I needed it to. I've got to make a support here that will hold a bearing. I was going to take some stock that I had and use this to bring it out to where it needed to be. And I was going to use this right here to machine apart, put a thing in here for a bearing, go to the other end. But this mystery steel is something you can't cut. I mean, you can with a carbide insert, but a bandsaw won't touch it. So I don't know what that is, but that ain't going to work. So I think what I'm going to do is make a different one that I can adjust slightly up and down and left and right to where I can dial this in perfectly. So while I was waiting on this, I went ahead and ordered bearings for this. So I've got some bearings that fit that surface coming in, and I'm kind of waiting to finish all this until all that comes in, so I've got them in hand. I happen to have these two bearings. I bought a bunch of packs for a different project from eBay, and one of these bearings just happened to fit on the end of this one. And wouldn't you know it, but this block that was back here, so I'm going to stick that out. See, the bearing actually fits on the end of this one. And you can't see that. Where'd my flashlight go? Okay. There it is. There we go. And it actually fits into that. So I was able to reuse this block, bolt it all back up. The only thing it doesn't do is it allows it to come in this way. So I'm going to have to hold it this way using these threads here. So this used to be, I don't know if I've got the other piece of that. What do I do with it? Oh shoot, I don't know what I did with it. Oh, so I took my bandsaw and I cut out there this piece. So this used to be one piece. I cut it, put it on the lathe, and turned this down to where I had a nice face here. And, you know, I was going to make a completely new piece for this, but I don't think I'm going to have to. I think I can just reuse this piece. So this will bolt on here. And this is a 34 or 35 millimeter. And you can see it just barely fits in there. So what I've got to do is I've got to have one of these, and then a bearing, and then one more of those. There's half of it. I don't know where the balls went. So you've got to have a stack sort of like this. So you've got your bearings that hold it from going this way and this way, your thrust washers, thrust bearings, whatever you want to call them, and then your bearing to let it smoothly turn this way. So this being a 34 or a 35, I think it's 35, I've got a 12 millimeter ID by 32 millimeter OD bearing. So I'm going to wait and bore this out when I get the bearing so I can make sure everything fits. But basically I've got 32 millimeter OD bearings and 32 millimeter OD thrust bearings coming. So I'm going to have two of these and one of these, and they're going to be the same diameter. So they'll slide in to that 32 millimeter opening here whenever I bore that in. And then whenever I get my thing in, I'll be able to screw this in, and I should be able to, if I have to, set some spacers and some other stuff like that to get this to be exactly where I want it. But once I do that, then this is going to be right where I need it to be. So another thing I went ahead and did, and I can't really, there it is I plasma cut this piece. So this is just a test piece to kind of get an idea of how I'm going to connect to this. So that lines up with these bolt holes here, like so. And what's good about being able to do this with a plasma table is, hang on, let me just turn that. I can tell right now, for one, this shape isn't going to work. I've got some down here. See, this is cut off here across the bottom. So I'm going to have to take my shape and cut it down here. So give myself some relief, because it's really tight in here. This was actually made for that. So you can see they had plenty of access around this screw. And with this, you can just kind of grind it away and you know, give it the relief that it needs in order to get around, where this is kind of what I've got. So whenever I get this perfectly centered up, I'm going to travel back and forth with this. What I think I'm going to end up having to do is grind down one side of this block to where, and then instead of it traveling back and forth like this, I'm going to have to grind down one side and it'll travel back and forth like this, because I don't know if you can see that. Let's see here. Get a flashlight in there. Okay, so this is trying to hit that bolt right there. So I'm going to have to relieve it here. And if I move it like this, you can see I barely have any room here. I barely have any room here. I basically have no room back here. So, you know, I may actually end up having to do something with that. Hopefully it'll be something as simple as just taking a hammer and kind of tapping it over out of my way, but I don't know how that's going to work. So if you look at it, I'm centered up. I just barely have enough room to travel forward and backwards. But once I get to here, I'm hitting this area down here. So I'm going to have to grind the bottom part down to where when this travels through there, there we go. See if I can get it to travel. Oops. So you can see it. Let me hold it there. Okay. So I am sitting on the bottom here. And as you can see, I'm not centered here. So if I were centered there, I would actually hit that. Just this slop is allowing me to ride over top of that. Oh, come on. There we go. Sorry, I'm trying to do this one-handed again. Trying to bring this. Okay, so I'm basically bottomed out here. And these fittings are interfering. So I'm going to have to figure out a way to limit this to where it stops here and stops here. So I have a specific set travel with this thing. So I think what I'm going to do, well, I'm not sure what I'm going to do yet, but I've got to figure out a way to relieve some of this. Another thing I considered is relieving all of these. So on the bottom have, well, actually, tell you what, let me do it this way. Well, yeah. So here's the ones I've got. I've got these thrust bearings coming. It's a 32 millimeter. And then I've got a 2-pack of these coming, and it's a 32 millimeter OD. So there's those, and there it is. So there's my model that I've got now. What I'm probably going to do is end up putting the flat towards the top of this, and I'm going to have to trim through here to get some relief, and I think I'm going to have to trim here and here to get a little bit of relief. So I may end up being able to use this hole, and this hole, but not this hole, and this hole, which I think is plenty. But this is what I'm eventually going to make. So that's a 1-inch thick block, and I'll probably redo some of my design, but that was what I made that flat piece out of. And what's nice about this is, yeah, it's not as accurate as a machine part, but this gives me something I can kind of test fit with, and I can see, oh, look at that, that's going to interfere there, and that's going to interfere here, and you know, if I do it this way, this is going to interfere there. So I can kind of stick it on here. I can make sure that my bolt holes line up with these bolt holes. You know, it's just kind of a quick and dirty way to do a test fit. And once I figure all this out, I can take this off, machine a new piece, and slide it on. And I'll probably machine it out of aluminum first and make sure everything works. This is also going to give me my height that I need. So once this is, let's see, find something flat. And this was just a guess. Once this is centered, which it's not, let me see if I can move that. There we go. Okay. So I'm going to use that to sort of center it. Oh, can't see what I'm doing. Okay. I'm going to kind of, there we go. So now, once I get this right, I'll be able to use this piece to measure my height up here for whatever I'm going to do here. I can measure from this surface, which is what we'll made up with this, to that surface to get the height needed to match to this, and use this to actually ride it back and forth. Now, I'm still debating on whether I'm going to use this or if I'm going to put linear rails here for this to ride on. I think the linear rails would work a lot better. It'd be a lot less friction and a lot less work on this. I'm also debating on, do I put a NEMA 23 or a NEMA 34 motor here? I know I'm going to put a 34 here, or maybe even bigger if I end up having to, but this one's going to have, I think, a little bit less torque on it, and it's actually a smaller rail. I've got a 12 millimeter. I don't know if I should have, well, let me grab that one. So that's the one that came out of it here, and this is what I'm putting in it. So you can see it's a size smaller than that one. Actually, I don't know what size that is. This is a 25, which is actually, that is the same thickness as that. So hopefully, hopefully this one's going to work out okay. I also thought about putting one of these on the other side here, to where I've got two of them moving it forward and backwards. I don't know if it's necessary. I think, you know, I'll probably be able to do everything with this setup. I may not be able to do super heavy cuts, which is fine. This is, I mean, I'm not doing production with this whenever I get it running. This is going to be a hobby machine / prototyping setup, to where the idea is this will do all the big stuff that won't do. So between this lathe and that lathe, at work, we do a lot of production stuff. And in all reality, this lathe right here will do everything we do at work on a regular basis. It's smaller, but most of the pieces we do at work that are production are that big. 99.9% of everything we do will fit in this work envelope. So this lathe would do the job beautifully for production. And this one will work for production. I can automate this one better and all that kind of stuff. So this is going to be my more production-oriented lathe. And again, I'm going to be able to do bushings. 99.9% of what I do really is making 28 bushings for a hydraulic project where I've got to, do something in particular. And every one of those are going to fit here. But every once in a while, I end up with something bigger. And this, I think, will do everything I need for that. So the D16 chuck is the same as my Howa. And I've already got 4 jaws. I've got collet chucks. I've got all that for this one. So it's going to fit this one. I'm also going to do doors here. And originally I was going to do doors where they slid and they kind of went past here so I could get in here. But what I think I'm going to do is overlapping doors. So I'll have an inner door and an outer door. And basically I can slide the 2 doors together. I can slide them both this way. I can slide them both that way. I'll be able to access everything I need to with my lathe. I'm going to make panels that bolt down here and up here. It'll come out probably just past this. So let's see. Let me get that in there. Yeah. So this is as far as this particular part is going to stick out. So you can see it's not sticking out that far past this part of my lathe. So I'm going to come up and up like this. So it's going to come out in an angle and up like this. And, I'll probably be somewhere in the neighborhood of that, where my door is, where my hand is there. So that's going to give me a little bit of room between these 2 machines. This is one of the irritating things about having a small shop. But, originally I was going to mount the servo motor like right here. But if you look at that, and by the time I mount a servo motor and everything, if I were to direct drive it, it would be massive. What I think I'm going to do is put a pulley here, like a bigger pulley, timing pulley, and then mount my servo motor under here. I'm going to use this as my template for a bolt pattern and make a plate that bolts to here. So it will be flush up under here. And then I'll have a piece that connects from here to the plate, so that will drive the carriage. And then I'm not sure if this is going to end up on this side of it, or on this side of it, or in the middle, or whatever. So I'm gonna do, when I make the plate, I'm going to do a bolt pattern here, a bolt pattern here, and a bolt pattern in the middle to figure out where I need to put it to get the travel that I'm looking for. Obviously I want to travel it all the way to here. So what I may do is move this all the way to here and see where this ends up on this. So if that works out, the only thing is if I put it way over here, I think it'll limit my travel that way. So when I roll back to here, that's as far as that piece can go. You know what? Actually, yeah. So that just told me, looking at it, I'm going to need it to be here. So it'll still roll back. I've got a tailstock there, so it can only go so far. You're going to have a tailstock sticking out to some degree. So if the bearing right here ends up here, then when it hits that point, my tooling is going to be somewhere in this vicinity, which is pretty much the max travel that I'm going to have between centers anyway. So I think I'm going to put it here, but I think I will set it up to where I can move it forward if I need to, just in case. But ideally, this will go here, and my motor can mount, you know, like up under here. So I'll probably offset it down, make a block that brings it down here so I don't interfere with this. And then the motor will mount up under here, little tiny pulley here, big pulley here, belt there, and then a sheet metal cover of some kind that will cover it. So whenever I put this on, I'll probably drill and tap for some bolt holes here and there for a base of a cover, plasma cut it out, and then plasma cut a laser, an outer ring that I can tack into place around it, and then the mirror of this back part on here that I can bolt in. It'll protect all of this and keep all that out of the coolant and all that good stuff. Put some weep holes down here so if coolant does get in it, it drops down. But yeah, I think this part is mostly figured out. This is going to be my next challenge. I think what I will do is take a piece of stock that I've got, find this diameter and this diameter and this distance from here to here to where I can slide this in, and I may make this part deeper and align this up with this. So it'll give me a way to align this, get my parts kind of put all together here, so I'll make the OD of my rod the same dimension as the OD of my bearing. That way when I line all this up, I can get the mounting bracket and everything put in exactly where it needs to go, exactly where I want it, with basically a guide rod here. And I'll probably figure out a way. I may drill and tap this bracket here to where when I screw it in, it's nice and solid. And then I'll probably take this with a indicator mount and indicate the rod to make sure it's level. You know, so I know level with this, so I can move this back and forth manually, just push and pull it like that, and sweep it with an indicator to make sure that this is exactly perpendicular with this. Once I do that, this will be ready to go. So that may be my next thing that I do. It'll probably be next week before I get all of my stuff that I ordered. But it looks like mechanically I should be pretty close to done here in the next week or so, at least mechanically with this. Then it's a matter of figuring out how to mount the servo motors, which I've already got a good idea of. The servo motor back here I'll probably mount facing this way, but mounted this way. So again, small pulley here, big pulley there, and that'll give me my travel forward and backwards here. I've got a plate somewhere. Oh wait, never mind. I'm sorry. I forgot. I've got to make a washer of some kind to go here that's going to mash this in to there whenever I get that done. So either way, but yeah, I mean, this is actually coming along really well. Looks like it's going to work out pretty good. I don't know what this went to. Now, it looks like it went to that, but I don't see how. What the world was that for? Huh. It looks like it goes, oh, okay. Yeah, so this is some kind of a cover for that. So I'll have to put a hole in this for that to stick out. Interesting. Either way, I'll get that done at some point. But anyway, so yeah, that's where I'm at with this. Slowly working through it. If anybody has any input, let me know. I'm open to suggestions. Obviously, I've never done this before, so this is all new to me. But it looks like I'm going to get this lathe working fairly quickly. What I may do, I've got a copy of Mach 3 I've got that. That's a Centroid controller, Acorn, all that kind of stuff. What I may do is just with Mach 3, because I know Mach 3. I've never really set that up. I know that, which is Centroid, but that's different. That's newer. But I've already got something set up on Mach 3 on a computer with kind of a test thing. I may use it once I get all this set up to just do some basic stuff, move things around, all that good stuff. Once I do that, I'll probably start working on the coolant pump, and I'll probably start designing my enclosure to go here. So I'm going to have a back piece that follows this and goes up. And I'm going to do it just above my head, which is going to be right at the angle or the height of that. So it's going to be, you know, another foot or two above that. So it'll probably take, I think that's 8 foot. I'll probably buy a 5x10 sheet of sheet metal from work, design it to where I can bend this way, that way, all the way there. So I'll measure this and figure out what the flat ends up being to where I can do that. And I'll have a flange. Matter of fact, what I may do is just make it flat to where I can bolt it to this face. So I can drill and tap here, bolt to that face. That'll probably be the simplest thing to do. This will actually give it strength on the bottom, and then have a flange up here that gives me something to bolt down to whenever I do the rest of this. And then I'll start piecing it together. So once I do the back part, I'll have the back covered. And then I'll make something here, but I'll probably have to put a relief in it for this. I'm also going to probably put a servo motor on this as well. So I'm not sure if I'm going to put a ball screw on this or not. I don't know if I'm going to need it. I may even do an air cylinder or something like that. I don't know. I hadn't figured that out. But if nothing else, I can always move it in manually, crank it in. But it would be kind of cool to have a second ball screw in the middle here, because there's nothing in the middle that would really move it in the way, and I wouldn't have to come but probably to here with the ball screw. But if I had one that traveled along that path, it would allow me to actually use a ball screw to move this in and out, and then have something, you know, maybe a hydraulic cylinder that would push this in and out instead of a screw like this. But if I could do that, man, that would actually be kind of cool. So you could automate that part of it. Either way, I'll figure that out. One of the things I was thinking about with this is if I put linear rails here, I thought about having a tool post here, but actually building another tool post that goes here with live tooling. So not only would I have a tool post here, make them both removable and fairly easy to remove, but have one that goes here and one that goes here, to where I could, you know, use this tool to come in and do work over here, and then maybe use a tool, you know, over here that could actually, so when this tool retracts out of the way, this tool could come in and do stuff as well. You know, I don't know. Or I may not do that at all. But what would be kind of cool is having at least some type of live tooling. That's one thing I would love to do, is be able to have some kind of live tooling on this machine. So, you know, a drill that could come in, an end mill that could mill this way. You know, they make spindles, Cat 40 spindles and things like that that you could use. So I don't know. I'll have to tinker with that some. But what would be really cool is if that would work, that would give me, you know, I could use an end mill to do a flat and then rotate this and then do a flat I would have to automate my spindle lock. See, that's got some slop to it. I'm not sure. So I may have to build a brake of some kind to where it will move to position and then brake to hold this in place. Either way, I'm going to start with basics first, make a standard lathe, because most of what I want to do anyway is like profiling, you know, something long. My dad's got a project, a bolt action rifle he wants me to work on, and he's got a bull barrel and he wants to turn it into a sporter barrel. So take off a lot of the material on the barrel, make it lighter, thread the end, stuff like that. So, you know, in all reality, that's what started this project right here. That's why I started doing this, is I wanted to be able to do a gun barrel, and that wouldn't do it. That would, but if I wanted a compound taper, you really won't CNC for that. So anyway, that's another story for another day, but starting to move along. Actually, you know, one of the things I've noticed with this kind of stuff is the more you do this, the easier it gets. It's really not that hard. It is daunting. You know, I would have never tried this at all, ever, 5-10 years ago. But really, the more I mess with this stuff, it's like, well, shoot, this is really not that hard. So, of course, I do have more tools now. Having, you know, a lathe that size to be able to make these changes, and having a mill like this to where when I do decide to make parts, I've got a nice way to do it on something like this, obviously makes a big difference. But what I may, I'm just looking forward to getting it done. So any input, let me know. Have a good day. Bye.